In Unit 11, we are going to be talking about radicals, specifically square roots. So some of our notes have cube roots as well, but we are going to use only the square roots. So this first part isn't super important because our index, that we call it, the little number that's in front of the radical sign, okay, ours is always going to be 2. So if it's n equals 2, we don't ever write it. All right, and that just simply means square root. So if there's no number in front of your radical sign, okay, this sign right here is actually called a radical sign, then it's assumed that your index is 2, meaning it's the square root. So all of ours will not have a number because we are just doing the square roots. The number underneath the radical sign is called the radicand. Not important, really, you're not going to have to do a quiz over it or anything, but just if you see that word in some of the notes, you'll know what it is. If you want to list out your perfect squares, you can, but you have that little sheet of paper. So I'll be going back and forth on my screen. So you have this little sheet of paper that gives your perfect squares, and then when you take the square root, you go back to the left. So the square root of 25, you look over and is 5. So our first ones, we're going to do all the odds on this video, and then I'll make another video with the evens. So our first one, 16, is on our list. You can also use your calculators. So for your calculators, some of you just have a square root button right away. Those of you that use my calculators, you'll have to push the second button, so that different colored button up in the left-hand corner. And then there's an x squared button. And when you push that, your screen should look like that, a square root sign with a parenthesis. Okay? You don't need to worry about the parentheses for what we do, but hopefully you know that the square root of 16 is 4. When we get down to number 3, this means 6 times the square root of 289. So again, if you want to type that in, you can, or if we take a look at our little note here, we have 289 on our list, so it's a perfect square. The square root then would be 17. So what this means is there's 2 ways you can do it. Some people can just cross that out and write the 17. All right, otherwise you might want to write out 6 times 17 for a final answer of 102. So again, a number out in front and then a square root means that you're multiplying those two. So take the square root first and then multiply the number in front of it to get your final answer. The main point of these notes is going to be this next part where we are going to simplify non-perfect square roots. So all of the rest of these do not show up on our perfect square list. Our job is to find the largest perfect square, so this is what number 1 says, that goes into 32. Now, 32 already poses a problem for us, so I'm going to show you 2 different ways that we can do this. So let's say that we know that 32 is 16 times 2. So what I do is I look at my perfect square list and I'm looking to find what numbers on that right-hand side, the perfect square list, go into 32. Well, 16, and it's 16 times 2 to give us 32. So we break apart and then put the square root signs around both of them. Technically, you are supposed to take the extra step of doing square root of 16 times 2 like that and then breaking them apart, but I don't feel the need to do that. Okay, so break it into 16 times 2, square root signs around both of them. The square root of 16 is 4. So the simplified version of the square root of 32 is 4 square root of 2. Now, there are some calculators that actually do this for you, so we will not be able to use those calculators. Okay, you actually have to understand how to do this. And I know it seems pointless, but this is something you're going to have to do for geometry. All right, now I said 32 is a little bit weird, and here's why. Some of us, when we look at our list, we know that 4 is a perfect square that goes into 32. Well, that's true, but 32 is 4 times 8. So if you did all of this work and you said 2 square root of 8 is your final answer, you are incorrect. And the reason is because that 8 has another perfect square in it. So you would have to go back and redo all of this again, break 8 into 4 times 2, square root signs. You got to bring this 2 right here, shows up right here. So 2 times the square root of 2 to finally get our answer of 4 square root of 2. So it's not wrong to do it this way. It's obviously just a lot longer. So you want to check your bigger square roots first to see what goes into it. All right. So if we look at 147, if I look at my sheet, okay, I don't want to start with 4. Okay, I want to start with something like maybe 64 or 81. All right, so you want to start with some bigger numbers that would possibly go into our 147. All right, so you're going to take 147 and divide it by, let's try 81. That doesn't work because I get a decimal. So go into means you divide it and you get a whole number. So then 81 didn't work, so I'm going to try 64. That doesn't work. So then I'm going to try 49. That one works. 147 divided by 49 is 3. So this gets broken into 49 times 3. So that's all it is just trying to find which number on the right-hand side of your list goes into the number underneath the square root. So 49 and 3, square root signs around both of them. Your final answer then is 7 square root of 3. If you want to make sure you have the correct answer, you would just type both of these two things in. So type in the square root of 147, figure out what that crazy decimal is. Type in 7 times the square root of 3, make sure it's the same decimal. Now, the only problem with that is if you up here in this one would have used 2 square root of 8, you also would have thought you were right because it would have had the same decimal. Okay, so you won't know that you're right unless you know that there's no more perfect squares underneath. All right, number 9 is another one very similar to number 5. So let me just kind of do this over to the side. If I know that 48 is 4 times 12, you should say to yourself, well, wait a second, 12 has a 4 in it. So if 4 goes in twice, that means 16 would go in. So some of you can do that kind of work off to the side or even in your head without having to write it all out. Okay, so if you find one number that goes in, you need to check and make sure the leftover number doesn't have a square root also. Okay, so 48 is 16 times 3. Square root, our final answer is 4 square root of 3. These last few just have a number in front. Okay, again, all that means, since there's nothing in between those two, is multiplication. So I'm going to bring my -5 down right away so I don't forget it. Then I need to break down 150. So I need to find which perfect square goes into 150. If you're not sure, just start dividing. 150 divided by 64 doesn't work. 150 divided by 36 doesn't work. 150 divided by 25 does work. So that's 25 times 6. Square root sign, square root sign. So -5 comes down, square root of 25 gets canceled out to 5, and then we have the square root of 6. So the last thing you need to do is actually multiply your two outside numbers to get -25 square root of 6. Now, don't think that just because this number was 25 that this number is going to be 25. If I would have had a 4 out here, then that would have been a -20, so it would not have matched. Our last one, -3 square root of 28. So bring down the -3 times, what perfect square goes into 28? That would be 4 times 7, square root sign around those two. So -3 times square root of 4 becomes 2, the square root of 7 comes along. So our final answer is -6 square root of 7. So again, you need to look at the right-hand side of that little paper at the perfect squares and figure out which one of those, and you want the biggest one, goes into the radicand, the number underneath the square root. Then you break it apart, take out the perfect square, and then multiply if you have to, like these last few.